Okay, this is STEM Day 6, and this is created specifically for my 8th graders so we can look at a chemical reaction. So in this you need water. You also need food coloring, just a few drops, and some sort of cooking oil. And you're just going to pour it straight into the cup. And I have my phone turned on with the flashlight underneath this jar so that you can better see the reaction. And what you're going to see here is that the oil and the water will not mix because they have different densities. So that in itself is a pretty cool visual. But the next thing we're going to do is add in 1 Alka-Seltzer tab. And when the Alka-Seltzer hits the water, we do have a chemical reaction occurring. Okay, so it is going, inside the Alka-Seltzer tab is sodium bicarbonate and citric acid. And when it hits the water, it's going to break into sodium citrate, carbon dioxide, which is going to be released in the form of gas, and water. So you can see those bubbles coming up, and they are rising up through the oil and then sinking back down into the water, and then the reaction continues to go until the Alka-Seltzer tab is depleted. So let's look at this reaction. So this is the actual chemical equation for the chemical reaction we just witnessed. The entire thing is the chemical equation. Okay, remember the big numbers out front are the coefficients, and the coefficients tell us the number of molecules of that chemical formula. The small number is the subscript, and the subscript just tells you the number of atoms within that element. So the coefficients are out front and the subscripts are below the element. So we have 3 of the sodium bicarbonates, 1 of the citric acids, 1 of the sodium citrates, 3 of the carbon dioxides, and 3 of the water molecules. So is this balanced? In order for it to be balanced, our products have to equal the reactants. So we're going to list our elements on each side before we count them. So we have sodium, hydrogen, carbon, and oxygen. So the reactants are always on the left side of the yield sign, and the products are on the right side. And remember, we call that arrow the yield sign because the reactants yield the products. Now we're going to count our atoms. So we have 3 sodiums because we say subscript times coefficient, and the subscript for sodium would be 1 times 3. And then for hydrogen we have 8 and 3, which is 11. Carbon, we're going to have 9 plus 6 because it's subscript times coefficient. And if there's not a coefficient, then we can assume it's 1. And then oxygen, we're going to have 9 plus 7. Then let's do it on the other side. We have 3 sodium, 5 plus 6 hydrogen, 6 plus 3 carbon, and that is 3 carbon because since there is not a subscript written, we can assume that it's 1, so it ends up being just 1 times 3. And then for oxygen, we have 7. And then it would be 2 times 3 would be 6, plus 3 times 1 would be 3. So we have 16 total. So let's make sure that our reactants equal our products on all the elements. And it's looking like they do. So when we answer, is it balanced? Yes, it is balanced.